Welcome back to the third part of Chapter 18, and we are in the home stretch now. We are talking about the ozone layer and how it's depleted and actually how it's recovering. So this is actually a good news story. So let's start with a little history though. Back in the 70s, it was first discovered that CFCs, I mentioned these before, chlorofluorocarbons, are these synthetic chemicals that are greenhouse gases, but they also do this thing where they deplete the ozone layer. Now, the ozone layer is really important because it actually protects all life on Earth by preventing damaging ultraviolet radiation, ultraviolet light from hitting the Earth's surface. Of course, ultraviolet light can lead to mutation. We talked about that way earlier in the semester. It also leads to decrease in photosynthesis in plants. So ozone depletion is a bad thing. Ozone in the upper atmosphere is a good thing. So these chlorofluorocarbons were actually interacting with the ozone and causing it to be depleted, especially really happening over the North and South Pole. And so this is where, what I was talking about a little bit earlier with global warming and deforestation and how we kind of needed to get cooperation involved and we needed to get everybody on board. We've done this before. This is a good news story. We've actually did this back in the 70s and 80s where we've realized that this hole was happening. We figured out the problem, and the entire world got together and reduced the production of CFCs. I mean, that's nothing but a good story. Of course, the problem was a little bit easier to deal with, and we are still making some CFCs, but just really decreased on the common everyday using of CFCs. Let's take a look, though, at what that hole looked like across the South Pole. So 1979, you see this hole starting to form. By 88, this is Antarctica here. The hole in the ozone layer is bigger than Antarctica. And but the rate of growth, I mean, this is huge, and this is just like 9 years. The rate of growth, once we put this CFC ban into place, or mostly ban into place, is that the rate of growth slowed down, it's stabilized, and we even see some shrinkage in the size. It's just a little bit. We still have a pretty darn big hole in the ozone layer, but it's starting to stabilize, and we are the beneficiaries of everybody coming together, seeing a problem and dealing with it. If only we could do the same thing for global warming. So this slide here is interesting because, yes, we use CFCs very casually back in the day. We use CFCs in hairspray and styrofoam containers and all kinds of propellants, and that's what we mostly got rid of. They are still used, unfortunately, in your refrigerator and in your car air conditioning, and they're still used in making aluminum, and so we still do have these uses. Hopefully, though, that we've done enough to help the ozone hole recover completely. I mean, it took some personal sacrifice. I mean, who wouldn't want this hair? That's my question to you. Who wouldn't want this hair? So, don't talk about it. Okay. So we've got all of these things that we need to do. And we originally started this whole conversation out by talking about biodiversity. And so we really have to start thinking about what we are going to do, who we are going to protect when we just have limited resources to do this. Are we going to protect this Egyptian tortoise? It's very cute. Or are we going to protect soil bacteria? Clearly not as cute, but maybe just as important. So So how are we going to decide what to do with our limited resources? Like in an ideal world, it would be great to protect all living things. Um, we don't live in an ideal world. We've got to figure out how we're going to protect most of our biodiversity that exists. Um, so, you know, maybe we have to think about our biodiversity in terms of genes and species and ecosystems, right? What level we're going to be protecting these things at. Um, what's the most valuable? And yeah, there we go, getting back to us being somewhat selfish. That might be what we have to think about. Look, there's pros and cons of all those goals of protecting ecosystems, protecting species, protecting genes, protecting species that maybe aren't beautiful, like soil bacteria. But we need a plan. Yeah. And we do kind of have a plan. We've got something called the Endangered Species Act. And this does inform conservation policy across the United States. And I'm so grateful that we have the Endangered Species Act because it's something that has protected our world, our land, and it's been a model for other countries across the world to use to help protect their beloved resources and animals and plants and so forth. So that's what the Endangered Species Act does, and it really only acts in the United States, but it is a model for other countries. So there's lots of different effective strategies, or there's different ways of thinking about effective strategies. First of all, we might just protect landscape. And this was first done back in the late 1800s after the Civil War. Yellowstone Park was created in 1872 and Yosemite was created in 1890. Those are the first national parks that were created in the entire world. So that's a good thing. We're protecting landscapes. And if you protect landscapes, then maybe you can protect the organisms that live in those landscapes. But of course, we humans have already divided up our landscapes quite a bit. So how do we preserve landscapes in the modern world where we've got, different patches of land that's a large patch here, and we got a patch here, and we got a patch here? Well, maybe we have corridors that allow animals to pass through to various locations. So we've got corridors connecting the various nature preserves. Or maybe we have these really large circular areas that's the nature preserve, but we've got a buffer zone in the middle where, it's not the nature preserve, but we've got rules that say, hey, no logging here, or let's minimize the amount of logging here, or let's not just be able to drive our cars all over the place. Let's, have a little bit of restriction. I think that that's probably a good idea. Both of them are good ideas. It depends on where you're talking about, which one would become more useful. We could protect individual species. So I mean that could happen, right? Not just ecosystems, but species. And those have been happening in the United States too, and around the world. If you protect individual species, there's usually something about the species that they find that they want to protect. For example, maybe a flagship species might be what we want. A flagship species is some very specific species that's particularly charismatic or distinctive, or like maybe it's vulnerable or some other way appealing to the public. Examples are like the giant panda in China, or the golden lion tamarin of Brazil, or the the bonobo in Africa, or leatherback sea turtles, or tigers, or elephants, or whatever, wolves, flagship species. The next one is keystone species, and this was something we talked about back in the previous chapter. Keystone species are species that have like a disproportionate effect on biodiversity of a community, right? So if they're removed, it changes the ecosystem massively. It changes the community like wild. So for example, if you remove the kelp from a kelp forest, you're not going to have a kelp forest. if you remove sea stars or beavers, these are things that we talked about in previous chapters. And very interestingly, turns out that wolves are a keystone species as well as a flagship species. When wolves are returned to Yellowstone, it changed the behavior of all kinds of organisms, and it actually changed the flow of the Yellowstone River just because they were returned. You should watch a video on that. It's really cool. Google it. Go to YouTube. Find that video. It's amazing. The next category that we're going to talk about are indicator species, and indicator species are any species whose, if it's present in the ecosystem, that means that the ecosystem is actually doing pretty well. We're going to do a lab on this idea of indicator species and thinking about how indicator species help determine whether a stream is polluted or not. Hey, you know, indicator species are useful. Let me give you a solid example besides someone we'll learn in lab. If there are no lichens on trees, lichens are those, like, they look kind of green, or sometimes they look brown or orange, but they're growing on trees. If the lichens are gone, that means that there's pollution. And if there's lots of pollution, then that can endanger the whole ecosystem. So that's what we mean by indicator species. And the last one is the umbrella species. And with umbrella species, these are umbrella species because they are wide-ranging species and they require large habitat. So if we can protect the umbrella species, we're actually protecting all the resources of all the organisms that live in the same range that the umbrella species lives in. So, you know, those are the kinds of things that we consider when we're thinking about conservation. The last thing that I want you to think about is that we can, and we have in the past, brought biodiversity back from the brink of extinction. And we do this, we attempt to do this a lot, but we have had some very specific examples. Captive breeding programs, by restoring habitat, by using zoos and botanical gardens as resources for using to put things back into nature. So a great example of this is the California condor. There was a captive breeding program for the California condor. They were on the brink of extinction. By, like, in the 1980s, the population had dropped to about, like, I think it was 22 individuals. There was poaching, there was poisoning, like, California condors are not beautiful. There was habitat loss, there was all kinds of things happening, but what they did was those 22 birds that had survived all of this stuff, the poisoning and poaching and habitat loss, they were brought into zoos and they were bred. And by 2016, the population had reached over 400. And they started releasing the birds into the wild. And now we know that the California condor is doing fine in the wild, but it's still being protected. It is still endangered. We see the same kind of things, like in wetlands that have been degraded by dredging and by, poison from, fertilizing your lawns and things along those lines. And we have reintroduced native species and restored water and stream flow patterns. And we've made these habitats, livable again for these native plants and animals. It's going to take a huge coordinated effort. And it can't ever stop because humans are, we're destructive organisms. But we're also repairing organisms, and I think that that's a good note to end on. A little bit hopeful, and hopefully you're not too depressed. Hopefully you can see that we as humans can make a difference in this world. So that's what I've got for you. If I can find my mouse, I'll end this talk. It was a good semester, and I hope you enjoyed this chapter.